In this video, I'm going to show you how to calculate formula mass. But first, I'm just going to let you know that it goes by a couple other different names. Molecular mass or molar mass or formula weight, molecular weight. There's a lot of different terms. And while they have slight variations as far as their meaning, the calculation really is exactly the same. The units may vary, and we'll talk about the units in a little bit. So let's start by looking at what formula mass is. Well, the formula mass is found by adding up the mass of all of the atoms in a given formula. So where do we find the mass? Well, on carbon here, we found the mass right underneath the name of the element, and the mass is 12.011. Now this is the average atomic mass. This isn't the mass of every atom, it's the mass of all of the atoms of carbon, an average mass of all of the atoms of carbon. Now there may be different isotopes of carbon that are heavier or lighter, but this is the average and this is the number that we will be using. So for fluorine, we'll be using 18.998 and so on. Now every periodic table has the masses in a different place. So use the periodic table that you're most comfortable with and find the masses on your periodic table. So here's a practice problem. What is the formula mass of sodium sulfide? Now in sodium sulfide, we have 2 atoms of sodium, and each atom of sodium has a mass of 22.989766928. In this periodic table, it gives you lots of places past the decimal, but in my videos, I round to the nearest 100th place. So we will round to the nearest 100th place, which gives us 22.99. So the mass of just the sodium atoms can be found by taking 2, the number of sodium atoms, times 22.99, the mass of 1 sodium atom, and I get 45.98. Now the sulfur atom has a mass of 32.06, and because there's no subscript after that S, we have just 1 atom of sulfur in this formula. So 1 times 32.06 is 32.06. So the mass of all of the sulfur in this formula is 32.06. So now we have to add these up, but I'm going to show you how I would add them up on a calculator so I could do this all in one step instead of breaking it apart into smaller steps. I would take parentheses 2 times 22.99, that's the mass of 1 sodium atom, close parentheses, plus open parentheses 1, the number of sulfur atoms, times 32.06, the mass of 1 sulfur atom, and then close parentheses and then hit equals. Now you don't need the 1 in there obviously in this situation, but I'm putting it in there to show you that there's only 1 sulfur atom. If you know enough about math, you'll know that you can leave that 1 out. Now I get a mass, when I do all of this, I get a mass of 78.04. Now my units for this depend on what the question is asking for. If it's asking for 1 formula unit or 1 molecule, you would answer in units or AMU. Now if you're asked to find the mass of a mole of this, you would answer in grams or grams per mole. Let's try one more practice problem. This one's a little bit more challenging because it contains some parentheses and a lot of different types of atoms. So what is the formula mass of ammonium sulfate? So we have some nitrogen, some hydrogen, some sulfur, and some oxygen. So we need to figure out how many atoms of each element we have and how heavy those atoms are. So let's start with our nitrogen. Now in that parentheses we have NH4, but there are 2 NH4s, which gives us 2 nitrogens. We have 2 nitrogens, and each nitrogen has a mass of 14.01, and then we have hydrogens. Now there are 2 NH4s, so we have 8 total hydrogens, and each hydrogen has a mass of 1.01. Then we have 1 sulfur and 4 oxygens with a mass of 16.00 each. Now as I show my work here, I'm putting each element in parentheses because I want to show each element individually. I even included the 1 for sulfur. You don't have to do this, but I've done it to show you that there's only 1 atom of sulfur. And then, so I've included my nitrogen, my hydrogen, my sulfur, and my oxygen. And now all I have to do is type all of this into a calculator, including those parentheses to keep the order of operations intact, and then I get my answer. So I have 2 times 14.01 plus 8 times 1.01 plus 1 times 32.06, and you can leave the 1 out, plus 4 times 16.00. And when I add all of this up, I get 132.16. So that is how you calculate and find the formula mass, or the molecular mass, or the molar mass of a substance.